Welcome to Science Access. In today's class, we'll be talking about questions and answers in valency. We'll still talk about the relationship between valency and oxidation. But if you have not watched my previous video on valency, please kindly watch it to give you a better understanding. Please subscribe to support the channel. Now, if I ask a very simple question, what is the valency of calcium or of oxygen in calcium oxide? All right. Calcium oxide is written like this. So, as usual, you can easily draw the structure of calcium and you can draw the structure of oxygen. Calcium is 20, oxygen is actually 8. All right. The first shell, for example, okay, let's assume that this is the nucleus of the calcium. The first shell takes 2, second, 8. The third one, we take another 8. Now, why is the first one taking 2? That's the maximum number of electrons that can actually enter the first shell. Why the second shell, the maximum number of electrons that can enter to be satisfied is actually 8. So let's put 2 plus 8 is 10. Plus 8 again is actually 18. So, and we have 20 here, so it's remaining 2 electrons. All right. So, note that this 20 here, the 2 electrons, I put it in the fourth shell. This 20 here is actually the atomic number, which is the number of proton. And the number of proton is equal to the number of electron. That's the reason why I'm using 20 as the number of electron in calcium that is actually uncombined. I'm not drawing the structure that is already combined. I'm drawing a single calcium first. All right. While for oxygen, we have something like this. This is the nucleus. The first shell will take 2. So let's use a different symbol. And the second shell we take 6. We take 6. All right. Now note, this second shell, how many is the maximum that can occupy this shell? Is actually 8. But how many do we have here? It's 2. And this shell here needs 8, but we have only 2 here. So this shell needs 8. We have only 6 here. All right. It's easier for this to donate this 2 to this than for this to donate 6 to this. So we can transfer these 2 electrons to this place. So that's the chemical reaction that you have as calcium oxide, which we now have the 2 being transferred from here to here. All right. Now note, this one, remember the number of electrons here before was 20 and the number of proton is actually 20. Proton is plus, while electron is what? Minus. All right. So we have 20 plus, have 20 plus, which is 20 proton plus 20. Then how many minus do we have? How many electrons do we have? If you lose, if this 2 is given out, you now have minus 18. So you now have a plus 2 as the net charge. So the oxidation number of calcium here is plus 2. Why its valency here is actually what? Just 2. The oxidation number of chlorine here, if it gains 2 electrons, what will it become? It will have 2 excess electrons, so it's now minus 2. But what is the valency of oxygen here? It's actually 2. The valency again, what is valency again? Valency of an element refers to the number of chemical bonds. Are you getting that? The atom can form with another atom to form a stable electronic structure. This stable electronic structure is what we are talking about, that this 8 is satisfied and this place is also satisfied. If it loses 2, so this shell is out, all right? So we now have the atomos share here is actually what? 8. So this is satisfied. So you realize that it's a very simple thing. What is the valency of calcium here is 2. What is the valency of oxygen here is 2. If I ask you another question, the simple way you can always do that is this. I won't be going through this long method again. All right, I'll be using a shortcut for the remaining questions. Now, if I ask you a very simple question, what is the valency of sulfur in a compound in which 2 sodium actually combine with what? 1 sulfur. So we now have 2 sodium, Na, then sulfur combined with 1 sulfur. We know that sodium has a +1 as the net charge. But if the plus 1 is multiplied by 2, what will it become? Now become what? Plus 2. All right, so the 2 together is plus what? 2. Simply means that for this to balance it, it must be what? Minus 2. All right. Now note this, please. Note this. So the oxidation number of sodium here is plus 1. The oxidation number of sulfur is actually minus 2. Now note this. Why the valency of sulfur here, which is the number of chemical bond that is formed, is 2. One bond combined with one sodium, the other bond combined with the other sodium. So it's actually 2 bonds that is formed. So the valency of sulfur here is actually what? 2. The valency is 2. So the easiest way to get valency, you can just calculate the oxidation number and remove the sign. That's the shortcut. The shortcut to get valency is calculate the oxidation number and remove the sign. So let's calculate the oxidation number of sulfur here. This is plus 1 times what? 2 plus what? X equals to 0. So this time this is now plus 2. We now have plus 2 plus x is equals to what? 0. Now take note of this. If I take this across the equal to sign, we now have x is equals to what? Minus what? 2. So this is the oxidation number of what? Sulfur. Just calculate the oxidation number of sulfur, then remove the sign. Even if it's plus, just put 2. If it's minus, just what? Put what? 2. So you don't need to put the sign. Just is a number. That is what? Valency. Take note that valency is a number. All right. Now let me ask you a very simple question. This is a compound H2SO4. What is the valency of sulfur in this? What do I need to do? It's simple. I just calculate the oxidation number. So I'll calculate the oxidation number of sulfur, then remove the sign. All right. How do I do that? This here is actually plus 1 times what? 2 plus x. It's x we are looking for, right? Then plus oxygen is minus what? 2. The oxidation number of oxygen is what? Actually minus 2. So we now have minus 2 times what? 4. Everything equals to what? 0. So we now have this time this is what? Plus 2 plus x. If you use this to multiply, this is minus 8. Minus times plus is minus. You now have minus what? 8 is equal to what? 0. So let's collect lighting. We'll now take this across the equal to sign, take this across the equal to sign. Now have x. If 8 goes across the equal to sign, we'll now have to now change to plus 8, which is the same thing as 8. While if this plus 2 go across the equal to sign, it will now become minus what? 2. So x here is actually x is equals to plus 6 as the oxidation number. Plus 6 is the oxidation number. So what is now the valency? The valency is simple. It's actually what? 6. I ask you what is the valency of calcium in calcium carbonate, CaCO3. We know that the valency of calcium is plus 2. So the answer is actually what? 2. So it's a very simple concept. The question is being displayed on the board. You can solve it and put your answer in the comment section. You can also take a picture of your workings, how you got the answer, send it to biologyaccess@gmail.com, and I'll reply you. Thank you for watching. Please subscribe.